The paradox of the plankton is the fact that there seems to be way too many species of plankton for what limited resources they have to share. Like, there are somewhere around 20,000 known species of phytoplankton, which are specifically plankton that can photosynthesize energy from the sun. And MIT estimates that there are likely around 100,000 different species of phytoplankton altogether. Individual plankton are called plankters, and it's estimated that there are 1 quintillion photosynthesizing plankters in the world's oceans. That's a million billion dang old plankters, and they produce about half the world's oxygen. And all those species of phytoplankton seem to compete for the same limited resources, like light, nitrates, phosphates, and iron. But in ecology, there's a principle called the competitive exclusion principle. When multiple species coexist in a habitat and compete for the same resources, one species generally outcompetes the others. And then that species dominates others with competitive advantage. So the other species will either go extinct, or they'll have to evolve or change their behavior to fulfill a different competitive niche. A classic example from ecologist Robert MacArthur in 1958 explains how 5 different species of warblers can coexist in spruce trees in Maine. All 5 species of warblers mostly eat insects and largely forage in spruce trees, so they seemingly directly compete with each other. But what he found is that the different warbler species primarily forage in different parts of the tree. The Cape May warbler forages in the valuable top part of the tree, and the myrtle warbler is resigned to foraging in the bottom parts of the tree. And when they stay in their own lane, they compete with each other less and have access to different insect prey. MacArthur called this way of getting around the competitive exclusion principle by carving out your own specific ecological niche, resource partitioning. For the other kind of example, North America's eastern gray squirrel was introduced into the UK in the late 1800s, where it competes with its native red squirrel. In the 1870s, there were an estimated 3.5 million red squirrels in the UK. But nowadays, there are only around 150,000 left. They don't even regularly fight each other directly, but the eastern gray squirrel has quite a number of advantages. First, they don't got their natural North American predators fucking with them. They also regularly carry and live with the squirrelpox virus, which quickly kills red squirrels. And on top of all that, red squirrels are larder hoarders and store all their nuts in a single spot. But gray squirrels are scatter hoarders and regularly pilfer the red squirrel's larder hoards. So if nothing's done about it, gray squirrels will probably eventually outcompete red squirrels in their entire Eurasian range, and the red squirrel will likely go extinct. Alright, back to plankton. Scientists have been trying to find ways to explain the diversity of plankton since 1961. That's when the paradox of the plankton was first described by ecologist G. Evelyn Hutchinson. He suggested a few ways to resolve the paradox himself, like how light behaves in the ocean. Obviously it gets deeper the darker you go, but different wavelengths of light get absorbed at different rates. Red light gets absorbed faster than blue light, which makes a vertical gradient of light in the water. And that means that life itself isn't actually a singular ecological resource. It's actually a multitude of different resources depending on how deep you are in the water. And it turns out that there's a huge variety of photosynthetic pigments that allow phytoplankton to absorb different wavelengths of light. Another explanation is that the ocean is hardly a static environment. Wind, waves, and competing currents create a chaotic environment, especially for microscopic organisms. So there might never be enough environmental consistency for any single species to hold on to its competitive advantage. Yet another possible explanation is called the boom and busted or kill the winner hypothesis. The idea is that viruses mediate how successful individual species of phytoplankton can be, because it's estimated that viruses kill about 20% of all the bacteria in the ocean every single day. And when conditions are just right for any specific species, they have a bloom and outcompete other nearby species. Sometimes you can even see plankton blooms from space. But having so many of the same species congregating in the same place makes a perfect opportunity for the viruses to come in and take them down a peg. And when they get wiped out, other species find a new spot to hang and reproduce. Altogether, there are dozens of possible explanations that resolve the plankton paradox. And many scientists believe that there will always be enough chaotic shit going on in the ocean for no single species to ever retain their favor. So there will always be surprising diversity amongst them.